Hey guys, this is your last shape of your thing. It's the volume of a sphere. So a sphere is a 3D ball, pretty much like the shape of a globe or a basketball or any type of ball shape that you have. It's a perfect sphere, round shape in this case. You can think of it as a 3D circle, a flat circle. So basically, we want to find how much stuff can go inside the volume of a sphere in this case. So you're thinking of anything in this case of as much stuff you can put in. So what we're going to do here is, if you need to find the volume of a sphere, you can pull it out on your reference sheet, and it's located right down here at the bottom. And you can see that we're taking 4/3 times pi times the radius cubed. So if I remember that pi is going to equal 3.14, and r is the radius, which is half the distance of a circle. So it kind of looks like so. Remember that you have your circle right there. There's a radius. It's halfway across the circle, so half the distance of a circle. Remember, if you have a diameter, the diameter goes from one end to the other. So we're going to be doing radius in this case, and we're not squaring it, but this time we're taking to the third power. So what I would do here is I would write down that formula here every single time. So I know I'm taking, this case, I'm taking 4/3, and I'm going to multiply it by pi and the radius to the third power. And it's going to find me the volume of a sphere. So let's do a few examples here, and I'll let you go through here, okay? So I'm going to do number one. So number one here, we have a sphere, the diameter it has a diameter of 9, okay? And what I want to know is I want to know what is the volume of this sphere. When I find it, I want to find it in terms of pi, in pi units, and I also want to find it in the standard form or to the nearest tenth. So let's just apply our information that we have. Okay, so sometimes I may need a separate sheet of paper. I'm going to put this on a separate sheet of paper so we have room to work it out here. So here's number one. So number one here. So what I'm given to here is I know that I have a diameter of 9, but I need the radius. So the radius here is going to be 9 divided by 2. So the radius is 4.5. So now I have my radius. And now I have everything that I need to know to find my volume. Using my formula, 4/3 times pi times the radius cubed. I'm just going to fill in what I have. So I have 4/3 times pi times the radius cubed, which is 4.5 cubed. I'm going to find it in pi terms first. So I can put that right into my calculator. And when I find that here in this term here, what I'm going to do is, I'm just going to put it right in there. I'm going to put by parentheses 4 divided by 3 times 4.5 to the third power. So I'm going to have to hit the caret button and 3. Makes it to the third power. And I hit enter, and it gives me 121.5. Now remember, that's the volume in pi terms, 121 pi. So I can look here on my paper, 121 pi in this case, and I'm looking and I see that the one that's the closest one here for me will be this one. So I would draw a line to that one. So then I want to know, well, what is it in units to the nearest tenth? Well, now I'm just going to take this and I'm going to multiply 121.5 times 3.14. 121.5 times 3.14 and 381.51, and I can find that it goes right there. So now I have that answer there correct. So I know that number one goes with here and it goes with here using my formula for pi. So this would actually have been 121.5 pi, and when I multiply that by 3.14, we ended up finding our answer there, 3.815 units cubed. Okay, so that's how you're going to be doing numbers 2, 3, 4, and 5. So be careful of your radiuses or whatever that needs to be done. Okay, so what happens if I come down to, let's see here, if I go to another page here that you're going to be working on, I have some pictures here. Same thing, volume of a sphere. Okay, I'm given the formula here, and I just need to apply it and see what I need to have. So if I look through here on number one is a radius. It goes halfway across, so I don't need half that. I can use 12. So I can be able to plug that into my formula. If I don't remember the formula is up there, I can pull out my blue sheet, and it's always located right there as well. So let's work that one out. Let's take a look to see what happens. So if I want to work that one out, and we're going to not put it in pi terms, but I'm just going to work it out as volume equals pi times the radius cubed times 4/3. Okay, so I'm ready to plug in what I know. I know that pi is 3.14. I know that the radius is given to me as 12 because it's halfway across and I have to cube it. And I know I need to multiply that by 4/3. So now I just need to do my math, put it into my calculator, and it can be handy for me to do this. So let's see how you do it. You're going to put parentheses 4 divided by 3 times 3.14, my pi, times 12. Now to get my cube, I'm going to hit the button right below clear, and then put a 3. So it's going to be 12 to the third power. Hit enter, and it gives me my answer of 7,234.56 cubic centimeters. So I can write that down here on my sheet of paper that I'm working on. And that is my solution. So my solution here for number 1 is 7,234.56 cubic centimeters. And that's it. Just applying my method. So the big thing I need to know is, okay, if I look at like number 5. Number 5, it has all the way across, a diameter. A diameter I don't want, that's a no-no. I need to have a radius. This is a diameter, so what would be, so I know my diameter is 34. What would the radius be? Well, the radius here is half of that, would become 17. So I would use 17 as my radius, plug it into my formula, so it would be 4/3 times 3.14 times 17 cubed, punch that into my calculator, and voila, I have my solution. Okay? Now let's do one more example here, and I'm going to leave you alone to work on these. Then what happens if I have one of these pictures here? And let's take a look at number 6. I have a half of a sphere. This half a sphere is called a hemisphere. A hemisphere is half of a sphere. Well, you're thinking, well, Mr. O, how am I going to do that math? Well, guess what? We can do that. We're going to treat it as if it is a sphere, and then since it's half of a sphere, we're going to just cut it in half or divide by 2. So we're going to solve this as if it was a whole sphere, and then divide it in half or divide it by 2 since it's only half. So let's work that one out. So I'm going to pull out my paper here. We're looking at number 6. So what information do I have here on number 6? So I'm given here a radius since it's half. So I know that my radius on number 6 is 15 inches. I can now jot down my formula, 4/3 times pi r cubed, and fill in what I know. So I know 4/3. I know pi is 3.14, and I know the radius is 15 cubed. So I'm going to put this in to my calculator here. Let's do one more here. So remember, I'm going to put parentheses 4 divided by 3 times 3.14 times my radius, which is 15, and I'm cubing it. Hit the caret, which is right underneath the clear button, 3 to make my third power. Hit enter, and I get the volume is 14 130. But remember, that was if it was a full sphere. But it's not a full sphere, it's half of it. So what I need to do is, this was if it was a full sphere. So what I need to do is, I need to take that and divide it by 2. When I divide that by 2, it will tell me my hemisphere's volume. So this is the hemisphere's volume right here. And so my hemisphere can hold 7,065 cubic inches. That's how you find the volume of a sphere and a hemisphere. So use these to help you solve your questions. Thank you very much. Bye-bye.